Hi, so today question is maximum sum of three non-overlapping subarrays. So in this we have been given an integer array nums and integer k that will be the size of the subarray, and we have to find three subarray which have the maximum sum and they don't overlap each other. So what I mean by that, like in this case for the first example, there are we need to find three subarrays of size 2. So we have found a array subarray at index 0, so then the sum will be 1 plus 2, that I have shown 3. Then another one at index 3, that will be from starting from here, so the sum will be 2 plus 6. With the red I am showing it will be 8. And then the third one is 5, so this one, like the green one, it is showing it will be 12. So our sum which is coming is 3 plus 8 plus 12, which is equal to 23. So this we have to find out. So there will be two doubts which you will be thinking, why we didn't pick this 13. So the problem with this greedy approach is, if we try to pick the largest one, I suppose I have taken 13 in my answer, then you can see that if the subarray 13 is making a part with this 6, so we can't take 8. So our answer will be, and we can't even take this 12 because this 7 is the part in 13, like if you can see here. So our answer will be, we will be taking this as 6 and this as 3. So our answer will be 22, which is less than 23. And that's why greedy won't work like this if it go to the sub array which has the maximum sum. And another thing, like you will be thinking that why we took this 1 comma 2, not 2 comma 1. Like if we have taken this one and this one, so we could have taken this one, but we took this one. See, the sum of these both are 3, 3. But here in the question there is written one thing, return lexicographically smallest one. That's why we chose the index 0. Okay, so for this question, my first intuition was that I need three subset A, B, C, which are of size k, and they have maximum sum. So suppose I have taken this as A, then this part I have to find B and C. So recursively, if I have taken somewhere B here, so in this part I have to find C. But then I thought I am focusing on the wrong person here, A. Like, what if it will be better if we, instead of focusing on A, we focus on B. So if we focus on B, suppose B is at here, this subset I have taken as B, then I have two array in which I have to find a sub array of size k that has maximum sum. So here I have to find A and here I have to find C. So this will be more simplified approach. Okay, so now my focus will be B instead of A. So how I thought I can do it is, like, what will be the suitable range for B first of all. Like if B is the center part, then you can say that on the left side of the B cannot be the part of this thing, like this area. Like this will be the size of k equal to 2. So it is a possibility of A. Similarly, this part size k equal to 2, this can be a possibility for C, but B cannot be the part of this area, like 5 or 1. It cannot cross it. The range for which the B will be there will be this one, because we want non-overlapping subarrays. Okay, so now once we are clear with this, I have something else. Now, what I thought, if suppose I have fixed my b here, over here, this is my b. So what if I pre-compute my answer such that here, like I have a array, complete array, but here what I store, like what is the maximum sum of sub array in this area, in this this array. Like here, if you can see, if I am at 6, and if I look like from this area, like from 5 to 7, what is the sub array of size k that has maximum sum? So you can say 12 here, and here it will be, I will be also storing the index, since we don't only need sum, we need to return index. So the sub array which is starting is at index 5, so I can store it something like 12 comma 5. Similarly, here it is our answer for C. Similarly, on the left hand side, if I see what will be my potential A, so here in this case there are only two elements, so I can say the potential answer will be 3, and it is starting at index 0. Sorry, here it will be 1, my bad. So here you can see there will be two candidate, one is this and another one can be this, but both sum is same, but we have to give lexicographically smallest. So instead of 1, like considering this one, I will consider this one, so it will be 0. So if you see, if we have taken this as example, then what will be our sum? That will be 3 plus, what is the sum, 8 plus 12, that is equal to 23. Okay, so from here what we can conclude, we have to do two pre-processing. First pre-processing for the left part, that will give us the max sum in that subarray with index, and second one will be the pre-processing for right, that will also give max sum with index. So let's look the dry run for this approach, and then we can move forward. Now let us run through our example. First of all, our window size is here 2 and our current sum is 0. So we will start from here, and it is not equal to our window size, that is k. So we will be directly adding it at as 1, and it is starting at index 0, so it will be 0. Then we will be expanding our window. So here our window expanded like this, 1 comma 2. So our sum is here at index 1. Like what we are trying to do here is, if I'm at index 1, so whatever including 1 to the left side of 1, we are finding in that subarray a subarray of size 2 that has the maximum length. So here in this portion we have an array of size 2 that has the maximum length of 2, and the maximum sum is 3, and it is starting where? It is starting at index 0, so it will be 0. Again our window will move forward, so from here it will be something like this. Again the sum here is 3, and what is the maximum sum up till the point 1? I am comparing it with this. So we will be seeing that both the sum are 3, but since we need a lexicographically smallest answer, we won't be updating it, and we will be writing it here 3 comma 0. Again our window will shrink and expand. It will be shrink from here and it will expand here. So again our sum will be equal to 3, and we will be comparing that at when we have the value only till here, what is the sum? Like the sum of this part is 3, And what if the sum here, like what is there, we are comparing, since both the sum are same, so we will be taking the previous sum. So again it will be 3 comma 0. Now our again window will expand, and now we will add 6 to it. So now current sum becomes 8. So if we see what we have found here, like if we have a subarray from 0 to 4, there lies a subarray of size k that is equal to 2, and whether it is greater than the subarray in this person. No, the sum is not greater, so it will be greater and we will be updating it. So if we are at 4 in this portion, we have a subarray of size 8 and that start at index 3. Now if we move forward, our window will shift from 6 to 7. This is our new window. So now our sum will become 6 plus 7, that is equal to 13. So again what we are trying to calculate, if I am at index 5, then what is the maximum sum for a subarray of size 2, that is coming as 13. So we are comparing it to our previous, and this current is more than the previous, so we will update it as 13. And where it is starting at index number 4. Again our window will move forward, our sum will be 7 plus 5, that is equal to 12. Since in this whole subarray, what is the maximum subarray sum of length 2, that is this one. So this new subarray won't give us the right answer, so here it will again come 13 comma 4, and here in the last our sum will become 5 plus 1, that is equal to 6. Again it, if we are considering this whole array, then what is the, like to the left side of this index including 7, what is the sub array of length k that has maximum sum, so that is 13 comma 4. Again, yeah, so like that we populated the left array. Now similarly for the right array we will do the same thing. I will write, since the maximum value of 6, like the maximum value here of c can be this part, like it is one possible candidate, so I am filling it with 6, 1 comma 6. Then for this part, what is the sub array of size 2, window sum is 5 plus 1, that is 6, and it is starting at index 6. Similarly, one second, our window will expand. Now this time it will be expanding. This was our original window, now it will expand to this, so it will be 7 plus 5. Now what we are trying here, if I am at index 5 and I want to find a subarray of size k that is here in this subarray and has the maximum sum. So at index 6 it is 6, but when we are including this index, then we are getting w sum, that is window sum, and it is equal to 12. So we are comparing, if including this element, what is our sum, like what will be the maximum sum, or if we are not including this element, suppose somewhere here we have a subarray that is of maximum sum, so that we are comparing. So we are comparing this 12 with 6. Definitely including this 7 and 5 is more better choice, so we will be updating here that if we are at index 5, the maximum sum which we can get is 12, and it starts at index number 5. Now again our window will increase in the left side, So now this time we have 6 plus 1 plus 7, and our window will be something like here. So here the sum is 13. Again, if we are including 6 in our window, then this subarray, which is of size 2, is maximum than the this side, like right hand side. So we can say that if we are including this whole array, then including 4 index, this whole subarray, the maximum sum will be 13 at index number 4. And similarly, if we move ahead like this, it will become 8. Again we will compare, it will become 13 comma 4. Then again we will compare it like this, and again 2 comma 1, it is 3. But again our maximum sum in this whole array, like right hand side including 2, will be 13 comma 4 and 13 comma 4 and 13 comma 4. Like this we have populated both the left and right arrays. Now what we will do with these pre-computation, we will be finding our actual answer. So okay, now what we will do, now as I told earlier that our b can lie in this range only, not 5 included, in this range only. So here our a can lie, or here like initial answer will be like this. So I have taken a sliding window sum, that will be window sum, and the window sum I have taken here, our window is of size 2, k equal to 2. So I have started from here and our window is like here, like this. So the window sum is 3 and I am here. Like this will be my start and end pointer, or I or j, you can take it anyone. So here for the algorithm we can take it as start and end pointer. So our window starts here, this is the start, this is the end. So what I am doing here, you can say that start is at 2 and end is at 1. Now what I will do, I will check one, since what is the minimum criteria that two subset does not overlap, like this a subset should not include this 2. So simply start -1, I can start from here, like this whole portion can include a. So what I am doing now, here in the left side I am checking at index 1 what is the subset I can get. The subset which I am able to get is 3 and it starts on index 0. So first let us update my maximum sum. In the initial was int me, and here I am computing my sum of a, b and c subarray. So here I will denote. So b is starting at index 2 and it has a sum of 3. I am taking the sum 3 from the window size. And a, what I am doing, a is like from the left at s minus 1 index. S minus 1 index is 1, like s is 2, 2 minus 1 equal to 1. So in left I am checking, okay, 3 is the sum which I am able to get. So 3 I am able to get, and what is the starting index for 3? It will be 0, 0. Now for the right hand side I am doing what is the least minimum criteria that they don't overlap. I start from e plus 1, like this will be my right hand side. So in this area I am checking what is the maximum sum for a subset of a sub array of size 2. So here it will be, for C it will be E plus 1. So the window is ending here. Only on the right hand side I am checking, that is the index number 4. I am checking what what is the sum I am getting. So the sum I am getting is 13 and it is coming at index number 4. So it will be equal to 3 plus 3 equal to 6 and this will be equal to 19. So for the first iteration our answer will be updated to 19 and the result will be 2 comma 0 comma 2 comma 4. Okay, done. This is done. This ABC is done. Now again our B window will shift, our B window will shift from here to here. Now the window sum is 2 plus 3. Start and end is also updated. Now start is on 2 and end is on, sorry, start is on 3 and end is on 4. So window sum will be 2 plus 6 equal to 8. Again for B our sum is equal to 8. So for A what we will do, again going back here asking from the left, hey left, tell me what is the sum I can get from the sub array starting from 0 till 2. So it tells that we have a sub array of maximum sum 3 that starts on 0, and for 8 it will be B, it is starting on 3. This is the index thing. Again for the right hand side for C what we are checking, hey C tell me what is the sub array I can get when I am starting from 5 till end. So it is telling if you start from 5 the maximum value of the sub array is 12. So I get 12 and where it is starting at index number 5. Okay, so this is done. So once this is done, what will be the sum? It will be 23. It is maximum than our current sum. So what we will do, we will make it 22, sorry 23, and we will update our answer 0, 3, 5. Similarly we will move forward. We move forward here, our window increases from here, our start becomes 4 and end becomes 5. Start become 4, end become 5, our sum becomes 13, and again for the ABC value we check. For B it is direct, that will be the window sum, that is 13. For A we will do just not including 4, we will come to here 3 and we ask 3, hey 3 what is the value, again it tells 3 with 0 and it starts at 4. Again I go to right hand side at 5. At 6 I ask, hey what is the maximum value you can give, so it gives 6 and it starts at index number 6. So again the value here if we add them it will be equivalent to 22, but we have already got a higher answer so we won't be moving forward, and similarly we will traverse and we will be able to find it. So the time complexity for this approach will be like O of 3n, y3, and which will be simplified to O of n, y3. First of all for this we are traversing O of n, we are traversing for this O of n, and for this also we are traversing O of n. Okay, now let's move to the coding part. Okay, so here we have started our function, and here we are finding the number of element. Then as I was telling that we need to generate two arrays that contain the pre-processed data for left and right side of current index. Like if we are at current index I, so what will be the sub array I will be getting from the left side that has the maximum value and has the length of k. So here this is that function left one. So here what I have done, I have taken a pair. The first int is to store the sum and the second int I am using to store the index value. Then here I and j are my start and end pointer, and w sum will be the window size sum. And since our window size is k, so I am directly like calculating that sum and appending that value in my left array. Then similarly, I am again incrementing our j, like we are syncing our window from the left side and increasing from the right hand side. So if the window shrinks, the window sum should be updated. That I am doing here. Then our j is incrementing. Again for I we are calculating the sum, and then we are checking whether this current sum, which by including the value at I, is more than the without including the value at I. So if it is more than the value including at index I, then we are including that sum, and the start of the window I am putting here, like the index is j. Otherwise we are giving the value, like we don't have any effect by including I. That's why we are giving the value without including I, and we are increasing I. Similarly, for the right hand side we are doing the same thing, just the code is little bit different, that instead of starting from the left hand side, we are starting from the end of the array, that is right hand side, and the value is initialized to the last index. And similarly we are finding the first window size sum, and similarly as we are incrementing, like we are shrinking the window and expanding to the left hand side, that's why we are removing the rightmost element of the window and then decrementing it. And similarly we are again adding the new element and checking whether including this element we are getting a subarray that has greater sum than the previous subarray to the right hand side, and again we are returning this array. Once we have both the arrays, what we are doing, as I told A and B and C, for that condition, that like our B will start from K, like K will be the starting point, because the minimum size, like the minimum value A can have is from 0 to K minus 1. So that's why we are starting from there. We are calculating the window sum from A, and then we are checking that this, for the first time what I have computed is correct or not, like the max, like we are just adding it as a potential answer, that is window sum. Then I'm adding the sum of the left hand side and right hand side, and in the result I am appending the indexes. And similarly I am expanding my windows, as my I can only go till n minus k, because the possibility where c will be there, it will be always in n minus k to n minus 1. Like if you see this, so the window size for C, the minimum possible value for C, as I was telling, it will be in the right hand side of the array having the window size of K. So for that we have this condition, and we are shrinking our window from left hand side and expanding in the right hand side, so that we are doing shrinking from left, expanding in right. And we are again comparing whether, if we are including the current value window, and after that the sum at the left hand side and the sub array at the right hand side, it is greater than our max sum, then we are updating the result, and in the end we are returning it. So let's run it. Let's see, it is accepted case. Now let's submit it. Okay, yeah, it is submitted. Yeah, thank you.